The 801A is a universal temperature alarm module that accepts inputs from thermocouples and RTDs or millivolt and resistance signals. It is software programmable, but after installation, the module can be calibrated without connection to a PC using the front panel push buttons. It has wide-ranging capability, allowing 8 different types of thermocouples and 3 different types of RTDs. There are 7 bipolar voltage ranges to select from, including a minimum input range of plus or minus 15 millivolts to a maximum of plus or minus 1 volt. A resistance range is also available for a 0 to 500 ohm input. Alarm set points in dead bands can be programmed to activate at any level within these ranges. 2 types of output ranges are available. The -0-100 suffix provides 1 double pole double throw relay, and the -0-200 suffix provides 2 single pole double throw relays. This instrument offers 6 different types of alarms to choose from, including limit, window, on-off controller, deviation, peak valley, and rate of change. Let's take a look at a graphical representation for each of the different types of alarms. All of these functions are selected using the Acromag IntelliPack software. The limit alarm trips on either a high alarm or a low alarm that is selected via the software. For a high alarm, normal operating conditions are below the set point. As the input signal rises, the output relay trips when the set point level is reached. Once the relay changes state, it will not return to the normal state until the input signal falls below a preset deadband level. This gap between the set point and the reset point prevents the relay from chattering due to unstable or rapidly changing inputs. For a low alarm, normal operating conditions are above the set point. As the input signal falls, the output relay trips when the set point level is reached. Once the relay changes state, it will not return to the normal state until the input signal rises above a preset deadband level. A window alarm has 2 trip points, or 2 limit alarms, one a high alarm and the other a low alarm. The area created between the 2 set points is defined as a window. If the input signal resides within this window, then it is in the normal operating condition. If the input signal rises to the high set point, or if it falls to the low set point, the output relay trips. Once the relay changes state, it will not return to the normal state until the input signal moves back into the window area beyond a preset deadband level. An on-off controller alarm uses 2 set points, a high and a low, each with no deadband. This creates a window area where the input signal is in the normal operating condition. As the input signal rises, the output relay trips when the high set point level is reached. Once the relay changes state, it will not return to the normal state until the input signal falls to reach the low set point. A deviation alarm compares 2 inputs and trips the output relay based upon the difference between the 2 signals, input A and input B. The direction of change between the 2 signals can be selected in the software. An alarm condition can be enabled based upon a positive change, A is greater than B, negative change, A is less than B, or an absolute change, which is either direction. The deviation function can only be selected in alarm modules able to accept 2 input signals. The peak valley alarm monitors a maximum level for a peak or a minimum level for a valley. The alarm function is enabled once the input signal exceeds a preset threshold. Beyond this level, for a peak, the alarm trips if the input decreases by a deadband change. For a valley, the alarm trips if the input rises by a deadband change. The output relay returns to the normal state after the input signal exceeds a preset dropout level. The rate of change alarm measures a signal's change within a 1-second period. If the rate in 1 second changes by more than a preset amount, the output relay trips. This change is an absolute amount triggered for changes in the positive or negative direction. The relay returns to the normal state once the input rate decreases below a preset dropout level. On the general page, choose the type of input, thermocouple, RTD, millivolt, or ohms. For RTD inputs, choose 2, 3, or 4 wire type inputs. Select the units, degrees in Celsius, Fahrenheit, or Kelvin. Switch cold junction compensation on for thermocouple wire inputs. Switch the CJC off for millivolt inputs or when simulating a thermocouple voltage using a copper wire connection. Choose upscale or downscale break detection. Upscale forces the input circuit to ramp up to the maximum end of the input range, tripping the output relay for high alarms. Downscale forces the input circuit to ramp down to the minimum end of the input range, tripping the output relay for low alarms. Select the type of alarm function. For dual output relays, two different alarm functions, independent of each other, can be selected. On the alarm configuration page, enter the setpoint and deadband. Select Failsafe or non-Failsafe mode. Failsafe is when the output relay is energized during normal operation. The continuity of the relay contacts is between the common and normally open terminals. When an alarm is triggered, the relay de-energizes and the continuity of the relay contacts changes to the common and the normally closed terminals. This feature protects the application from a loss of power to the module or to the internal relay. If the relay drops out and the module fails, an alarm is triggered notifying the user that the application is no longer being protected. If the module fails, it leaves the application safe or failsafe. Non-failsafe is when the output relay is de-energized during normal operation. The continuity of the relay contacts is between the common and normally closed terminals. When an alarm is triggered, the relay energizes and the continuity of the relay contacts changes to the common and the normally open terminals. Choose automatic reset or latching relay. Automatic operation resets a tripped relay once the input signal exceeds the deadband amount, returning the relay to the normal state. Latching the relay maintains an alarm condition until a manual action occurs to reset the relay. There are two ways to reset a latched relay. One is by pressing the RST button on the module, and the second is through the IntelliPack software. On the test page, clicking on the Reset Latch button also returns the relay to the normal state. However, the relay cannot be reset unless the input signal has returned past its set point in deadband levels. The time delay is a feature allowing a preset amount of time to be selected between 0 and 25.5 seconds. This is the amount of time an input signal must exceed a set point level before the alarm condition is enabled. This function helps to filter input transients and avoid false trips. This time delay applies to both relay activation and deactivation. The IntelliPack configuration software is available on a CD or can be retrieved from the Acromag website. It contains programs for all of the models in the IntelliPack series. After configuring the selected program, it is downloaded to the module through a serial port adapter, SPA, in cable assembly. The SPA contains an electronic circuit allowing a PC to communicate with the module. The software CD, cable, SPA, and user manual are combined into a kit. The part number for this kit is 900C-SIP. The program can be saved as a document file in your computer and printed out to obtain a hard copy. It can also be attached to an email. Any PC receiving the email can open the attachment provided the IntelliPack software is loaded in the computer. Another helpful feature is the ability to upload a program from a module to a PC. This may be necessary to determine the configuration of an unknown program or for monitoring or troubleshooting purposes. As software upgrades are issued, Acromag makes the latest version available from our website. Here are several examples of wiring diagrams for the 801A Universal Temperature Alarm Module. Diagrams for thermocouple, millivolt, resistance, and 4 different RTD wiring connections are shown. Be sure to maintain the correct polarity of the input connection. The RTD wiring configurations include 2-wire, 3-wire, 4-wire compensated loop, and 4-wire Kelvin. These different types influence the temperature measurement accuracy. In general, best accuracy is obtained with the 4-wire Kelvin connection type. The 3-wire and 4-wire compensated loop hookups will be slightly less accurate, while the 2-wire hookup is the least accurate since it implies that no lead resistance compensation will be performed.